When you're programming this, what exactly is the difference between working in LabVIEW and using a traditional programming language?
Well, with LabVIEW, what you have is a complete graphical system design platform that lets you start at the design phase and to design your control system and really fine-tune your parameters, and then go on to prototyping on a PC and finally being able to deploy it onto a compact Wii or FPGA or any sort of embedded device. And that's really what LabVIEW provides. In any robotic system, you really have four components. You have your sensing and actuation, and then you have the aspect of being able to run on the deployed platform, whether it's a FPGA, a microcontroller, or what have you. Then, of course, you have the aspect of control design, doing the algorithms. So all that needs to happen from a single design environment, and that's where you run into some walls with text-based languages, which may not have the I/O capabilities or the high-end algorithm capabilities, where LabVIEW really shines in that area.
Do you have any features built in that are specifically for robotic development?
Yes, so if you look at our control design and simulation module, it lets you design your control system. You can do advanced control, you can do PID, you can do LQR. So many different control parameters or control algorithms are built into that. And then on top of that, our machine tools and our motion tools and our vision tools are very appropriate in the sense that you can do vision acquisition in LabVIEW and then do image processing and so forth inside of LabVIEW.
At what level do you work with at LabVIEW when you're working with mechanical hardware here?
Well, if you're doing a model-based design, you would want to first create a mathematical model of your robotic arm. And once you've done that, you can simulate that within LabVIEW by providing the transfer function of your arm. And then you would design the controller to really control the arm if you wanted to do closed loop control. And that's where LabVIEW control design can help you build any sort of advanced controller. You could do model predictive control, for example, within LabVIEW. And so that's the design phase. And now let's say you have this control algorithm ready on this theoretical mathematical model. We know that doesn't really translate 100% to a true hardware. The middle phase is prototyping it. So you might have a smaller arm that's maybe not as destructive to really test out your algorithm and your parameters. And finally, once you have proven that your technology or your algorithms are tuned properly, you can deploy it onto a larger system, onto your full system.